Hey guys, today we are going to talk about perimeters and areas of similar figures. The area of similar polygons theorem says if two polygons are similar with lengths of corresponding sides in the ratio of A to B, then the ratio of their areas is A squared to B squared. So here we have two similar polygons, and I could write a ratio of their sides, a side of polygon 1 to a side of polygon 2, as A to B. And if the ratio of their sides is A to B, then the ratio of their areas is A squared to B squared. These can also be written as fractions, A over B, and A squared over B squared. The ratio of the sides is also the same as the ratio of the perimeters. So at times we'll refer to the perimeter ratio or the side ratio. Those mean the same thing. Okay, so here we have a red and a blue triangle, and they are similar. And we want the ratio of their perimeters, red to blue. So that means red will go first, blue second, or if it's a fraction, red on top and blue on bottom. And I'll write this as a fraction. So the perimeter ratio is red over blue, 8 over 12. And that can be simplified. 4 goes into 8 and 12 2 times and 3 times. The ratio of their areas, I simply take this perimeter ratio and square it. So we'll raise it to the second power. Okay, so the area ratio is 2 squared over 3 squared, which is 4 over 9. You are installing the same carpet in a bedroom and a den. The floors of the rooms are similar. So we have two rectangular rooms. They are similar to each other. The carpet for the bedroom costs $225. Carpet is sold by the square foot, which means that it's comparing areas. How much will it cost to carpet the den? So when we look at these two pictures, we can get a perimeter ratio based on the numbers we have here. The lengths of each room are 10 and 14. And that can be simplified to 5 over 7. 2 goes into 10 and 14, 5 times and 7 times. And because the cost of carpet is based on the area, we will take this and turn it into an area ratio by squaring it. So we've got 5 squared over 7 squared, which is 25 over 49. Now we can use this area ratio to write a proportion. So we have 25 is to 49 as, and that's the area ratio. The cost of the smaller room, which is $225, is to the cost of the larger room. So we'll do our cross products. We have 25x and 49 times 225. 11,025. And we can divide both sides by 25. And we get 441. So it should cost $441 to carpet the larger room, the den. So here are two triangles, and it says here that they are similar. The perimeter of triangle ABC is 16 feet. So I'll make a note here. Perimeter is 16 feet. And its area is 64 feet squared. The perimeter of triangle DEF is 12 feet. Given that they are similar, find the ratio of the area of ABC to DEF, then find the area of triangle DEF. So the perimeter ratio And we'll go in this order, ABC to DEF, so ABC on top is 16 over 12, which can simplify. 4 goes into each, 4 times and 3 times. So the perimeter ratio is 4 over 3. So the area ratio, we just take those numbers and square them. So that's 4 squared over 3 squared, which is 16 over 9. Okay, now it did say in the directions, find the area ratio, so I will put a box around that. That's part of our answer. Now find the area of triangle DEF. So I have an area ratio of 16 over 9, so 16 is to 9 as, and I've got the larger over smaller. This one has the larger perimeter, so it's going to have the larger area. 64 is to x. So my cross products are 16x and 9 times 64, 576. And divide by 16, and we get 36. So that means that the area of this figure here, triangle DEF, is 36 feet squared. A large rectangular baking pan is 15 inches long by 10 inches wide, so that would be this one right here, 15 by 10. A smaller pan is similar to the large pan. The area of the smaller pan is 96 inches squared. Find the width of the smaller pan. So we are given that the area of this smaller pan is 96 inches squared, and by doing length times width, we can find that the area of this larger pan is 150 inches squared. So what we can get out of this is an area ratio. So there are two ratios we're working with, the perimeter ratio and the area ratio. And what we can get this time is the area ratio. Okay, so the area ratio is 150 to 96. So I can simplify this. 150 over 96. 6 goes into both of those. 6 goes into 150. 25 times. And 6 goes into 96 16 times. So the area ratio simplifies to 25 over 16. Now previously we've had a perimeter ratio and we would raise it to the second power to get the area ratio. This time we've got to go the opposite direction. We're going from area ratio to perimeter ratio. So we're going to have to do the opposite process, and that is taking the square root. So the perimeter ratio is the square root of 25 over the square root of 16, which is 5/4. So the perimeter ratio is 5/4. And remember, the perimeter ratio is the same as the ratio of side lengths. So I can use this to find this missing side length. So I'll write my proportion as 5 is to 4 as, this is what I'm missing. I've got bigger over smaller, so I'm going to go bigger over smaller. 10 is to x. So my cross products are 5x and 40. And when I divide by 5, I get x equals 8. So the length of this missing side is 8 inches. The floor of a gazebo is a regular octagon. Okay, so a regular octagon, that's an 8-sided figure, so it would look something like this. Each side of the floor is 8 feet, and the area is about 309 square feet. You build a small model. So a smaller octagon, and it's still a regular octagon. The perimeter of the floor of this model is 24 inches. Find the area of this floor to the nearest tenth of a square inch. Okay, now this larger one, I can find the perimeter easily. I have the perimeter of the small one, the perimeter of the larger one. Each side is 8. There are 8 sides. The perimeter is 64 feet. So I can write a perimeter ratio of 64 over 24. And 2 goes into both of those. 32 times and 12 times, and 2 goes into both of those as well. In fact, 4 goes into both of those. 8 times and 3 times. So the perimeter ratio simplifies to 8/3. The area ratio, so I'll take these and raise them to the second power, is 8 squared over 3 squared, 64 over 9. Okay, so I can write my proportion now as 64 is to 9 as, and I've got larger over smaller. Larger area is to smaller area. 309 is to x. Now this larger area is in feet squared. This one is in inches squared. That is not going to matter. I've got feet over inches on both sides, so that's going to be okay. So I can do my cross product. 64x equals 9 times 309, so that's 2,781, and divide by 64. So we have 43.5. 43.5 inches squared. The ratio of the areas of 2 regular decagons is 20 to 36. So we've got our 2 different ratios, the perimeter ratio and the area ratio. And we are told here that the area ratio is 20 over 36. What is the ratio of their corresponding side lengths in simplest radical form? So here I'm really just trying to find out what is the perimeter ratio or the side length ratio. Same thing. So what I need to do is take the square root of these numbers. So the square root of 20 over the square root of 36. The square root of 36 is 6. The square root of 20, we need to simplify that. 4 is a square number that goes into 20. It goes in 5 times. So the square root of 20 is the same as the square root of 4 times 5. The square root of 4 is 2. So 2 times the square root of 5 is the simplified form. So there is the square root of 20 in simplest radical form. Now 2 over 6 can be simplified. 2 goes into each 1 time. So it's 1 times the square root of 5 and 3 times. So the square root of 5 over 3 is the area of, or the ratio of side lengths in simplest radical form. And last we have 2 similar rectangles, rectangle 1 and rectangle 2. So the perimeter of rectangle 1 is 66 inches. Rectangle 2 is 35 feet long by 20 feet wide. Find the ratio of the areas and find the area of rectangle 1. Okay, so here we can find the perimeter easily. So we have 35 plus 35 plus 20 plus 20. Or we can simplify that to 2 times 35 plus 2 times 20. So we get the perimeter here all the way around is 110 feet. Okay, so from that we can get a perimeter ratio. So the perimeter ratio is 66 over 110. Now we want the area ratio. Okay, now we have to figure out what goes into both of these, both 66 and 110. 66 and 110, I believe, are both divisible by 22. So let's use that. 66 divided by 22 is 3, and 110 divided by 22 is 5. So that simplifies to 3 over 5. Now to get the area ratio, we will square those. So 3 squared over 5 squared is 9 over 25. So it did say find the area ratio, so I'll put a box around that. That is part of our answer. Now use that area ratio to find the area of rectangle 1. We don't have the area of rectangle 2, so let's find that. It's 35 times 20. Length times width. So the area here is 700 feet squared. So our proportion will be 9 is to 25 as, and that's smaller over larger, so we'll put the smaller area, x, over the larger area, 700. So we have 25x equals 9 times 700, 6,300. And divide by 25. And we get 252. So the area of this smaller figure is 252 inches squared.